Okay, so now all are here, right? Everyone is here. Okay, so the thing is, uh, we'll try to finish syllabus by November 30th. Okay, minimum you should be ready 60 to 70%. Okay, yes, yes. So ready means what? What do you mean by ready? Ready for a test means what? Huh? Your confidence level, right? You should be excited to write test. Okay, remember. Yes, yes. So be excited when you are prepared. Then you want a test, right or not? So your preparation should be like that. You want test. Give me paper. I will write test like that. Are you getting or not? So 60% to 70% you should be ready. Okay. So normally it happens. We think NEET is in May, right? Till then we have time. Now time will decrease, right or not? August, September, correct or not? Then later on you will analyze how much you are ready. Okay, how much syllabus you know. Okay, how many questions you are able to solve. Which subject you have problem. Like that you think like that. Okay, no, increase your confidence. Okay, how you can increase your confidence? Okay, books, you should have books first of all. If you don't have books, even now you get it. Okay, books are very important, personal books. So because it is your reference. Okay, it is your reference. In library also books are there, you can have it. Okay, books means NCRT should be there. Okay, you have Arihant. Okay, Arihant publication, Disha publication, RLS is there. Okay, RLS book is also good. Okay, right? So RLS book is there, Disha is there, Arihant is there, Singage is there. So Singage, all are NEET books. Okay, all are NEET books. So these books should be there. This is the minimum requirement. Are you getting? I know some of you are not having books. Okay, get it. Okay, books are very important. Okay, then after you have books, what you will do? Many of you are solving MCQs. Okay, so start with basic questions. Normally, when I teach, I start with basic questions only. Okay, small questions like one step questions, one step questions. Okay, one step questions will boost your confidence. Okay, one step questions will boost your confidence, right? So one step question, confidence is important. Are you getting or not? Don't solve high level question, big questions don't solve initially. Okay, first you have to build your confidence. Are you getting or not? So solve one step question only, correct? So from your books. Okay, if any doubt is there, immediately ask. Okay, so doubts are also important. Okay, doubts means you are not understanding some line, you are not understanding some step. Okay, not not getting some step, or line, some line you are not understanding. Okay, clear it immediately. It is very important. Think like that. The thing you are not understanding, it will come in your exam. Think like that. Okay, so even if it is a one line or two line, or one question is there, or one step is there, numerical question is there, vector question is there, calculus is there. Okay, differentiation is there. Okay, immediately you clear your doubt. This is very important. Don't keep it. I have seen students, they keep their doubt in their mind. They do not clear it. Okay, and later they suffer because uh, in actual need, very familiar question will come, and you will think, oh, I studied this question in the book, but it was not clear. I should have cleared it. In the NEET exam, student think like this. Okay, so and I'm not saying these things first time for you. Okay, every year, yes, yes, every year to every student I tell these things. What? What are these things? What are the main important things? Clear your doubts. Okay, even small physics is like that only. Physics subject you can learn from books, okay, and share your knowledge. Okay, so clear your doubts, right? Don't keep it. Okay, these are the minimum requirement. Now hard work. See, there is no limit of hard work, right or not? There is no limit of hard work. Hard work means how many MCQs you are solving per day, how many MCQs solving per day. Okay, make a target. Make a target. Today I will solve 10 questions. Okay, 20 questions. Increase your target. Okay, so maximum, keep your target maximum as possible. Maximum as possible. Don't be minimum. Okay, at least I should solve 10. At least I should solve 5. At least I should solve 20. No, I should solve maximum 30, not less than 30, not less than 40. Are you getting or not? So keep your target maximum. So hard work is important or not? It is important. Okay, because it is a big exam. You understand first. It is a big exam. Okay, your life will be set after this. Okay, so that is important. You give importance to hard work. Okay, so and doubts clear, and by November 30, 60, 70% you should be ready. Okay, then by February, okay, February last you should be 100% ready. Think like this. Yes, yes. Ah, yes. So February last you should be 100% ready. Are you getting or not? 60 to 70% ready by November. Okay, in all subject. Some student think I will do physics now. After December, bio. I will focus more on bio. Right or not? How you are managing? It is up to you. Like some student do bio now. After December, I will learn physics. Okay. Do you think like this? Are you planning like this? Okay. No, go parallel. All subject parallel you go. Okay, no problem. Parallel all subjects. You make a timetable. You make a timetable. 2 hours you have to give minimum to physics. Okay, in your hard work. How many questions you can solve in 2 hours? That 2 hours can be afternoon, evening, night, early morning. Okay, 2 hours you give extra. Okay, so parallel go with all subject, because what happens, you focus more on one subject, you will get good marks in that subject, definitely, right? But other subject will suffer, right or not? Correct or not? Suppose you are studying physics every day, all time you are studying physics, bio marks will suffer, chemistry marks will suffer, correct or not? I know some students attempt physics first, so their physics marks are good, maybe 140, 160. I know students score this much mark, but bio is less, 100. Bio is 100, chemistry 110, like this. So bio marks are less, correct or not? If you are focusing more on biology, maybe 360 you will get biology, but physics and chemistry marks will suffer. Are you getting or not? So it is better to go parallel. Give importance equally. Physics is also important in your medical field. Also, the knowledge of physics will help you. Okay, like modern physics, magnetic field, correct, electrostatics. Now machines are there in which concepts of magnetic fields are required, right or not? Like that, you know any machine in which magnetic field concept is required? MRI, correct. Good. So, okay, clear. So physics is important. It is interesting subject. You can gain interest in that. Okay, fine. So parallel, go parallel in absolute. Now I'm starting the topic. So now, so laws of motion. Note down Newton's laws of motion. Newton's laws of motion. Correct. So see, I'm starting from basic, and actually I have covered little bit of this chapter before also. Okay, that also I will revise. Okay, so first of all, motion, we have studied motion. What is motion? Change in position with respect to time. Change in position with respect to time. So that is known as motion. correct? Now position means what, you know. What is position? Suppose this is the x-axis, x is equal to 0. So observer is located at x equal to 0. This is the observer, correct? Now this is x equal to 1, x equal to 2. Suppose some particle is there or any student is there. It is walking on this x-axis. So suppose initial distance is 0.5 meter. After some time 1 meter, after some time 2 meter, correct? So position x is changing. So that means the person is in motion. Okay, person is in motion with respect to observer, correct? So that is motion, right? Change in position with respect to time, correct? Then what is Newton's laws of motion? What is Newton's laws of motion? And law, what is a law? Something which is natural, okay? Something like gravity. Gravity is not man-made. Gravity is natural, right or not? Like before humans were there, gravity was there, right? Anything you release, it will fall towards earth. So that is gravity. So anything which is natural, that is known as laws. Electrostatic is also law, right? Charge. That's why we study Coulomb's law, correct? You remember? Electrostatic Coulomb's law is there. Then in magnetic field, Biot-Savart's law, right? These all are natural phenomena. So anything which is related to natural phenomena, that is known as law. Natural phenomena, okay? Natural phenomena. So we call it law. So then Newton, because Newton gave explanation, that's why we call it Newton's laws of motion. So basically, there is a story also. There was a tree and apple fell, correct? Apple. So Newton saw that apple. Uh, why it is falling down only, correct? Why that apple is falling down only? Suppose this is the apple. Why it is falling down only? When it is released, like when the apple is, this is the branch of the tree. This is the branch of tree. Okay. So this is the branch of tree. Now this apple is there. So when it is detached, when it is detached, when it is detached from the tree, it will fall down. When it is connected with the tree, it is not moving. Means it is at rest. It is at rest. Like this, I am holding this object. This object I am holding. So what is the state? It is at rest. But when I detach it, now it is falling. Okay. So why it is falling? That is a question. Okay. That is a question. Why it is falling? You tell me why it is falling. Gravity, correct. So when it is attached with the tree, why it is not falling? When it is attached with tree, why it is not falling? Hmm? Gravity is not acting at that time. Gravity is acting at that time or not? When it is attached, like gravity is acting on this pen or not? Yes. So why it is not falling now? Equal and opposite force. Very good. I am stopping it from falling. If I lose it, it will fall. Okay. So now what I am doing with this object? I am exerting equal and opposite force. Okay. Equal and opposite force. So now the concept of force. Okay. So gravity is pulling it down. Gravity is pulling it down. So if I detach it, it will fall down. But if I am holding it, I am stopping it from falling. So I am exerting force where? Where? What is the direction of my force? Upward, because gravity is pulling it down. So I should exert upward force to balance it. Okay. So now the concept of balanced force is there. I have covered these topics before also, but quickly I will revise. Okay. Balanced forces and unbalanced forces. Okay. What do you mean by balanced forces and unbalanced forces? So first of all, what is the force? What is the force? When I say force, force is, what do you mean by this force? What is a force? You see nuclear force, okay? We talk about nuclear force, we talk about gravitational force, correct? Electric force, electric force. What is common in all these? Nuclear force, gravitational force, electric force. These are all forces, okay? Friction force is there, electromagnetic force is there, electromagnetic force is there, correct? So force means what? What is a force? Yes, in simple words you can memorize pull or push. In early classes also you have learned this. Okay, pull or push is known as force. Okay, so pull means what? You're attracting something, you want something to come close to you. Like for example, see, so suppose this is the I have taken this example in vector also. Suppose one person is standing at the top of building, okay, and another person is also standing behind. So A and B. So A is standing at the top of building, correct? Now B is just behind. What B can do to A? What B can do to A? It can push it or pull it. Okay, so the result is completely opposite result. If it is pushing A will fall down and die. If uh, B is pulling it, the life of A is saved, correct or not? Completely extreme, extreme results, life, death, like extreme results, correct? So push and pull, you imagine. So push and pull means it is related to direction, correct? Then similarly in chemistry also, you like suppose H2 molecule is there, so HH atoms are there. They are pulling it or pushing each other. They are pulling each other because attractive force is acting, correct? So attractive force is there, correct? That is known as bond, correct or not? So in chemistry, the meaning of bond is force only, correct? So when attractive force is there, so it is a force, pull force, correct? Then push force. Example of push force. What is the example of push force? Like plus and plus, positive charges, two positive charges, what they do? They push each other, correct? So suppose this is charge A, this is charge B. So A will push B like this and B will push A like this. So this is how you represent force. Okay. So this is the representation of, this is force. Okay. Represent push force. Okay. If it is minus and plus, so they will attract. They will attract. Okay. So this is using arrow. Using arrow and line segment, you represent force, correct? So if it is a push or pull, you have to understand if it is a push or pull. So identifying a force, whether it is push or pull, is important. So then one more definition is there for force. One more definition is there. It is an interaction. It is an interaction between two objects. You can note down this, or particles. It is an interaction between two objects or particles. That is known as force, correct? Now interaction means what? Interaction means what? Push or pull. Interaction means push or pull. Okay. Now we'll take some example from this classroom. Okay. Like this fan. How fan is interacting with ceiling? Tell me. You tell me. Fan and ceiling, how they're interacting. This is the ceiling and this is the fan. Okay. This fan is there. How it is interacting with the ceiling? Tell me. Like push and pull, you have to tell. Interaction means push or pull. Tell me. Pull. Very good. Fan is pulling the ceiling down. So how ceiling is interacting with the fan? Ceiling is also pulling the fan up. Are you getting or not? See, because gravity is pulling this fan down, correct? So ceiling is holding it. Ceiling is holding fan from falling, from falling due to gravity. So gravity, because of gravity, this fan will fall, right? So, but ceiling is what ceiling is doing? It is holding it like this pen. Same thing with pen also. Gravity is pulling it down, but I am holding it. If I lose the grip, it will fall. Correct? So same thing, the fan is connected with the ceiling. So what is the direction of force on the ceiling due to fan? Direction of force on the ceiling due to fan. No, force on fan due to ceiling is upward. See, force on fan, force on fan due to ceiling is upward. What is the force on ceiling due to fan? Downward. Okay. So imagine if very heavy, fan is very heavy, and ceiling is not strong. What will happen to ceiling? Ceiling will fall. Correct or not? Because this fan is pulling it down. Correct. So you have to identify this push or pull. Okay. So now in case of ceiling and fan, it is pull. Now you tell me, I'm pushing this wall like now I have told only. Okay, it is push. So what is this force? Push. I'm pushing this wall. Okay. So suppose there is a wall and there is a person which is pushing this wall. Okay. So this is an example of push. This person is pushing. So what is the direction of force on the wall? Direction of force on the wall in this diagram, left side. So this is the force on wall. Correct. So the wall will also push the person. What is the direction of that force? This way. So this is the force on person. Okay. So you see, the ceiling is pulling this fan up, fan is pulling the ceiling down, person is pushing the wall left. So wall is pushing the person right. What you are observing in these two examples? What you are observing? This is example of pull. This is example of push. What you are observing? They are in pairs. Are you getting? They are in pairs. So one force is there, so another force is also there. Are you getting? So interaction is like that only. Correct? So like two students are talking to each other. Only one is speaking, other is listening. Is that interaction? No. Both should talk and both should listen. That is what? Interaction. So here also person is exerting force on wall and wall is exerting force on person. So that is pair. So force exists in pair. Okay, it is, these are known as real forces. What is real force? Note down. What is a real force? You can note down. Real force means which exists in pair. Real for real force exists in pair. Okay, there is a unreal force also, like pseudo force. You know, have you heard about pseudo force? Imaginary force. Okay, that is not real force. So real force exists in pair. Like for example, moon. Suppose this is the moon and earth. Moon and earth. What they are doing to each other? They are pushing or pulling each other? They are pulling each other. Earth is pulling the moon towards it, and moon is also pulling earth towards it. Okay, so they are one. This is the force on moon. Okay, and this is the force on earth. So both are pulling each other. So pair, correct. So positive charge also there. Like suppose this charge is A, this charge is B. So A will repel B, B will repel A. Okay, B will repel A. So that is pairs. Correct or not? So force exists in pairs. Remember, real force exists in pair. Then some more important point regarding force. The fundamental forces. What are the fundamental forces? Have you heard about this fundamental forces? So scientists and researchers, they categorize forces in four parts. Okay, in in sequence you memorize the weakest. Which is the weakest force? Which force is the weakest in the universe? Gravity. Good. So note down. Gravitational force. Gravitational force is the weakest. After that, weak nuclear force. Weak, you memorize this, okay? Weak nuclear force. After that, electromagnetic force. Electromagnetic force. And which is the strongest force? Strong nuclear force. Strong nuclear force. Okay, strong nuclear force. So strong nuclear force is between neutron and proton, neutron and proton, and weak nuclear force is between subnuclear particles, subnuclear particles like mesons, okay, sub subnuclear particles like mesons, okay. So just remember this, okay. And the gravitational force, we know that between masses, it is a pull force, it is a pull force between mass mass objects, matter, okay. And electromagnetic force is also known as contact force. Sometimes it is contact, sometimes not in contact, or it can be contact force, it can be non-contact also. Remember this. So a statement I'm saying, you tell me true or false. Electromagnetic force is always contact force. True or false? False. Electromagnetic force may be non-contact force. True or false? True. So give example of contact force, which is electromagnetic. So we will learn about these forces: tension force, normal force, okay, friction force, tension, normal, friction force. These are contact forces, correct? All contact forces are electromagnetic in nature. This line also you memorize. All contact forces are electromagnetic. All contact forces are electromagnetic, okay, remember. So if there is any contact force, so that must be electromagnetic, memorize it, okay. So statement I am saying, uh, all contact forces must be electromagnetic. True or false? All contact forces must be electromagnetic. True or false? All contact forces are electromagnetic, so true, correct. All electromagnetic forces are contact forces. True or false? Now it is false. Okay. See, non-contact electromagnetic force means like point charges are there. Okay. Force between 2 point charges. Force between 2 point charges. Like two charges are there. One charge, another charge. They are not in contact, but they can repel each other. They can attract each other. Like one is positive, another is positive. So positive, positive, what they will do? Repel. Positive, negative, what they will do? Attract. But there is no contact. Physical contact is not there. Okay. No physical contact. So non-contact means no physical contact. They are not touching each other. Okay. No physical contact. Contact means physical contact is there. So example of contact forces: tension force, normal force, friction force. Okay, fine. Non-contact electromagnetic force, force between two charges, you can say magnetic force also, but I'm not going in detail. We are just discussing introduction. So remember, just two lines you remember. All electromagnetic forces can be contact or non-contact. Contact must be electromagnetic. Non-contact must be electromagnetic, can I say? You can note down these statements. All all contact forces must be electromagnetic. All contact forces must be electromagnetic. True or false? True. Very good. It is true. Then all non-contact forces must be electromagnetic. True or false? Now this is false. Correct. Good. Why? Because gravitational force is contact or non-contact force? Non-contact. Contact is not required. Okay. Gravitational force is a non-contact force. Like Earth and Moon, they are not touching each other, right? There is a space between them, but they are exerting force. So Earth and Moon are pulling each other. So that is gravitational force, which is non-contact force. Okay, are you getting? So contact force, non-contact force. Okay. So all contact force must be electromagnetic, that is true, and all non-contact forces must be electromagnetic, that is false. So reason is gravitational force. You can note down, gravitational force is a non-contact and is not electromagnetic, and is not electromagnetic. Okay, gravitational force is a non-contact and is not electromagnetic. It is not electromagnetic. So now you see, okay, let's go back to previous. Okay, fine. So weak as you first you memorize this sequence. Okay, strongest is strong nuclear force, weakest is gravitational force. Which force is mostly seen in universe? Mostly gravitational is mostly. Okay, most of the most of the examples are based on gravitational force. Okay, fine. Okay, done. Okay, contact non-contact over. So push and pull. Okay, now let's start with let's go back to Newton's laws of motion. Now Newton's laws of motion. Okay, so law of inertia. What is inertia? Let's talk about law of inertia, and it is known as Newton's first law. Newton's first law. Okay, so how many laws are there? Three laws are there. Okay, so first law, it is also known as law of inertia. Why Newton's laws of Newton's first law is also known as law of inertia? Why? So it is described in NCERT book also. So first of all, you understand what is inertia. Law, you know, law is something natural. Natural, that is law. But inertia means what? What is inertia? Inertia means, in one line you can remember, a position to change. A position to change. A position to change. So you can say object at rest cannot move by itself. Object at rest cannot move by itself. We need external force to move it. Like this chair. Chair is at rest or not? Chair rest or not? It is rest. You have to exert force. Now only it will move. Correct? By itself it cannot move. So what type of force is needed to move an object? External or internal? External. Object at rest cannot move by itself. We need external force to move it. This is known as inertia of rest. This is known as inertia of rest. Inertia of rest. Okay. Remember, inertia of rest. We have so many examples in this room. Fan. Right now, fan is at rest. Correct. This board is also at rest. A clock is at rest. The table is at rest. So they cannot move by itself. Correct or not? So that is known as inertia of rest. Now suppose you have dropped some object. Now this pen is moving. Okay. You observe this pen is moving. Now I catched it. I catched it. Okay. So I stopped it motion. I stopped its motion. Correct or not? Before catch, the pen was moving. See. Now I stopped its motion. So motion can be stopped only when force is applied. Okay. So see, what is inertia of motion? What is inertia of motion? Tell me, what is inertia of motion? Correct. Object cannot come to rest, cannot come to rest by itself. Object cannot come to rest by itself. We need, again, same answer. What is needed to bring object to rest? What is needed? Force is needed. What type of force? External. So external force is needed. External force is needed to stop it. Okay, we have so many examples. We can take examples from sports. Okay, like cricket is there, so ball is there. Okay, batsman is there, so batsman will hit the ball. Now fielding is there, so some person will catch the ball. Correct. So ball is coming like this is the ball. Ball is coming like this. Ball is coming, imagine ball is coming. Now player is holding the hand like this. Okay, so these are the hands. Okay, so now what will happen? The ball is coming like this and you are holding the hands like this. What you are trying to do? What you are trying to do? You want to stop the ball, correct or not? So what hand is doing with the ball? What hand is doing with the ball? Tell me. Exerting force. What type of force? External force. Okay, so you are trying to stop the ball. Okay, so ball, you are catching the ball means you are exerting force. Correct. So external force is needed to stop it. That is known as inertia of motion. Okay, that is known as inertia of motion. So resistance to change, you can call it opposition to change, or you can also say resistance to change. Resistance, you can say opposition or resistance to change. Okay, fine, clear. So inertia, inertia means resistance. Like a cat, normally I take this example, cat and dog, which is more active? Normally dog is more active, always changing. Sitting, suddenly it will stand up and run, correct or not? Or coming, running, suddenly sit somewhere. But cat, you see, always sleeping, correct? So cat do not want to change in that state, correct? Sleeping cat. So it is inertia. Cat has more inertia. Like that, you can remember. Okay, inertia means resistance to change. One more meaning of inertia is there. Other meaning of inertia. What is the other meaning of inertia? Mass. Inertia is related to mass. Note down. Inertia is also mass. So more mass means more inertia. Like truck and cycle, which has more inertia? Truck and cycle, which has more inertia? Truck has more inertia because it has more mass. Okay, truck has more mass, so more inertia. Why? Why truck has more inertia? Mass, more mass means more inertia. Why? Because which object is easy to move? Truck or cycle? Cycle is easy to move. Cycle has less inertia. Truck is difficult to move. So truck has more inertia. Heavy object like elephant. Elephant and dog. Elephant and dog is there. Which is easy to move? Dog is easy to move. So dog has less mass, so less inertia. Elephant heavy, so difficult to move. So more mass, more inertia. More mass means more inertia. Remember this. Okay. So other meaning of inertia. Let's go back to Newton's laws of motion again. So what is the Newton's first law? So this is also known as law of inertia. Okay. So Newton's first law is also known as law of inertia. Now let's discuss more on this. So note down. So Newton's first law. Now again, I'm discussing this topic. So what is the statement? First you write down, it's a statement. Object is at rest. Object is at rest continuously. Okay. Object is at rest continuously if no external unbalanced force acts. It is easiest definition, you can say Newton's first law. Continuously means always, all the time, all the time. Like this chair is continuously at rest. Okay, all the time, right? So object is at rest continuously, not for a moment. Like for example, if you throw this object, now topmost point, what is the velocity? 0. So that object is at rest for a moment, correct or not? So I'm not talking about rest at a moment. I'm talking about rest continuously, like fan, continuously, trees, continuously at rest. Okay. If no external unbalanced force acting on it. Okay. So now what is the reverse? If there is no external unbalanced force, that means the object is at rest continuously. Okay, reverse is also true. If object is at rest continuously means there is no external force, unbalanced force, like clock is at rest, so no external force, unbalanced force, no external unbalanced force. Okay, so suppose I am saying, now I'm little bit one question I'm doing. Suppose there is a ball, there is a ball of mass m, there is a ball of mass m. Okay, and I'm saying no, no external force on it, no external unbalanced force acting on it. It means what? What is the state? It is in rest or motion? It is at rest, correct. And or uniform motion. Okay, there is one more point. So in bracket also you can write down uniform motion or uniform motion. So if there is no external force acting on it, so ball is at rest continuously or in uniform motion. So that is Newton's first law. So imagine there is a car, there is a car, it is going with 80 kilometer per hour. It is continuously going with 80 kilometer per hour. So you tell me the what is the state of this car? It is in uniform motion or rest? Uniform motion, because direction is also fixed. Direction is also fixed. Direction is fixed. East, you can say it is going east with 80 kilometer per hour. Okay. So what you can tell about forces? Is there any external unbalanced force or there is no external unbalanced force? There is external unbalanced force acting or no external unbalanced force? No external unbalanced force. Okay, so suppose the ball is at rest, so no external unbalanced force. Car is going with constant velocity, so again you can say no external unbalanced force. Okay, no external unbalanced force. Okay, let's take one more example, because these understandings are important. Suppose there is a seat. Normally, I think I have taken this example before also. You know this example. Suppose this is a car. Now this passenger is sitting. So this is the steering wheel. Okay. Headlight is there. So now this car is standing. Standing means at rest. So what is the meaning of external force? I am discussing meaning of external force. You can note down this. What is the meaning of external force? Okay. So this car is standing. The person is sitting on the rear seat. Okay. This is rear seat. Passenger is sitting on the rear seat. Car is at rest. Car is at rest. Now this passenger want car to move. Person want car to move. Okay. So what person is trying to do? It is pushing the it is pushing the front seat. Front seat it is pushing. Okay. So car will move or not? No. So why? Why? Force is internal. Good. So person is pushing front seat. Person is pushing front seat, trying to move car. Okay. But car will not move. Car will not move because the push from person is internal, because push force from person is internal. Okay. Okay, that push force is internal, so what is the problem? It is internal, so what? Internal, so what? Tell me. So see what happens. This person is pushing the seat. This is the front seat. Pushing. So front seat is experiencing force where? Front seat is experiencing force where? Right side. Correct. So front seat will also push person where? Left side. Okay. So force on front seat due to person right side. Force on person due to front seat is left side. Are you getting or not? They will cancel each other. They will cancel each other. So note down. Internal forces cancel each other. Note down. Very important point. Internal forces cancel each other. Internal forces cancel each other. Okay. Now this front seat is the part of the car. Front seat is the car only, car component. Correct or not? And passenger is also part of the car only. So front seat, both front seat and passenger are part or component of car. Okay, so they are internal. Okay, they are internal, so car will not move. Okay, car will not move. So internal forces cannot change the state of motion. Okay, so you can remember this line. Internal forces cannot move object. Okay, like this. But explosion is different thing. Okay, explosion, when you see explosion is there, suppose one object is there, it will explode, so you will see motion is there. Okay, but that is different concept. Okay, I'm not talking about that. The center of mass is the concept in that. Okay, I'm not talking about explosion. Okay, I'm talking about objects like chair. Okay, car, person is there. So I'm not talking about explosion. Okay, fine. So internal forces cannot move object. Okay, we need external force. Similarly, you have seen sometimes maybe somewhere you have seen this. Suppose there is a truck. There is a truck. There is a truck. Now there is a rod like this, and north pole, south pole is there. Very strong magnet is there, and in the truck also, in the front side, north pole, sorry, south and north, like this. Here south pole, here north pole. In the truck, this is the north, this is south, and here also north south. So south and north, they will attract or repel. They will attract. So what do you think? Now this magnet is attracted towards this magnet. So truck will move right side or not? It is a rod. It is iron rod. This is an iron rod. So tell me, they will move or not? Truck will move or not? Tell me. This north pole, south pole are attracting each other. So truck will move forward or not? Truck will move forward or not? Tell me. Truck move forward or not? Yes or no? Huh? Now think about internal and external forces. This is a truck. This magnet is part of the truck. This rod is also connected to truck. So this magnet is connected to rod. So all are one object only. Correct or not? So this magnet is external or internal? Internal only. Okay? It is internal only. So this magnet is internal. It is like this. Like suppose there is a person. Okay? And this is one hand, another hand. One hand is pulling another hand like this. The person will move or not? One hand is pulling other hand. The person will move or not? No, it will not move because internal. What type of force is needed? External. So if another person is pushing it, then this person will move. Okay. So same thing. So these all are one part of the truck only. This is complete truck. So internal forces. So this is the internal force. Okay, this is internal force. The attraction between this north and south. These are internal forces. So internal forces cancel each other. So the truck will not move. Okay. So answer is not. Okay, truck will not move. Okay, clear? Okay. Then what is unbalanced force? Suppose right side 1 Newton, now I am talking about some values also. So 1 Newton numerical values, 1 Newton right side, 2 Newton left side. So these are unbalanced force. 1 Newton right side, 2 Newton right side, and 5 Newton left side. These are unbalanced force. Or 1 Newton right side and 1 Newton up. This is unbalanced force. Okay. And an example of balanced force, tell me. Balanced forces. Right side 1 Newton, left side 1 Newton. Balanced force. Right side 1 Newton and right side 0.5 Newton also. Then left side 1.5 Newton. So these are balanced forces. Okay. So how many forces are there in this example? How many forces? Two forces. Okay. Here three forces. Here two forces. Two forces. Okay. Two forces. Here three forces. Okay, correct. So forces are represented like this. So you common tell generally how to represent forces, how to draw forces. So what you call this diagram? Free body diagram. What is free body diagram? What is free body diagram? Representation of forces. Okay, with a common tail. Uh, okay, representation of forces. Representation of forces with common tail. Okay, tails should be common. Like for example, suppose there is a next page I will discuss. Okay, suppose there is a person standing on the ground. Person is standing on the ground. You tell me how many forces acting on the person? How many forces on the person? Weight. Okay, earth is pulling it. Earth is pulling it down. One force, but person is not moving. Person is not moving. Weight is down, but person is not moving. Why? Person is not moving because correct. So you can say the forces are balanced. So surface will exert this. This is the ground. Okay, this ground surface will exert upward force. Okay, that is normal force. That is also known as normal force. Okay, and it is denoted by N, and weight is denoted by W. Correct. So now the forces are balanced. So suppose the mass of the person is 80 kg. So how much is weight? mg. So what is the formula? G is 10, correct? G is 10 meter per second square. Okay, so what is the weight of the person? 800 Newton. Mass is 80 kg. So what is the weight? Tell me in Newton. 800 Newton. And weight is downward and normal force is upward. So you can equate both. So N is equal to W. So that means N is equal to mg. So N is also 800 Newton. Okay. So upward 800 Newton is acting, downward 800 Newton is acting. So forces are balanced. Okay. So forces are balanced, so person is at rest. So force is balanced. Rest continuously, like I am standing here. What is the net force on me? Tell me. Zero. Okay. Correct. Good. So this is balanced forces. Okay. Note down. So let's talk about more balanced forces. When forces are balanced, it is also known as equilibrium. Equilibrium has so many meanings. In chemistry, you have some other meaning of equilibrium. In physics, only one meaning. Equilibrium means balanced forces. Okay. So equilibrium means balanced forces. So equilibrium object can be at rest or uniform motion. Uniform motion means velocity constant. Velocity constant. So now I am saying one statement. Okay. You tell me true or false. Note down. A student running, a student running with 5 meter per second. Okay, along east. Forces must be balanced. Forces must be balanced. Forces must be balanced. Tell me. So it is balanced. True or false? Tell me. A student is running with 5 meter per second along east continuously. Forces are balanced or not? It is a, so what is the state of motion? Rest or uniform motion? Uniform motion. Correct. Very good. So forces are balanced. So this statement is true or false? True. Okay. What is the reason? Tell me. Because it is in uniform motion. Uniform motion means velocity constant. Means it is in equilibrium. Means forces are balanced. Okay. Balanced forces. Okay. Clear? So it is true. Okay. Now one more statement. A student running east with 1 meter per second suddenly suddenly takes left turn, suddenly takes left turn while in motion, while in motion, suddenly takes left turn while in motion. So now you tell me, the forces are balanced or unbalanced? So I am writing, you tell me true or false. Okay, a student running east with 1 meter per second suddenly takes left turn while in motion with 1 meter per second, means speed is constant, means speed is not changing. Okay, forces must be balanced. True or false? Now, true or false, you tell. Uh, so it is false. Now this is false. Why? Reason, tell me. Direction changed. Very good. So direction changed. Okay. So direction is changed. To change the direction, force is needed. Okay. Unbalanced force is needed. So forces are not balanced here. Direction is changed. Previously, before, what is the direction? East. Now left turn. So what is the new direction? Previously east. Now left turn. So what is the new direction? North. Okay. So direction changed from east to north. So direction changed. Correct. So forces are balanced or unbalanced? Forces are balanced or unbalanced? No, no, no. For this case, unbalanced. Direction change means velocity change. Velocity change means unbalanced force. Are you getting? So this is unbalanced force. Okay. But question is saying forces must be balanced. So this is false. Are you? Everyone is getting? Okay. Good. Fine. Good. So this is false. Okay. So next you write down, to change direction of motion, unbalanced force is needed. I will give very good example for this. You are aware of it. Unbalanced force is needed to change direction of motion. We have example of football. Okay, so this, there is a football. Now football, how you play football? There is a ground. Okay, football is coming from there. Now goal is there. Now you want football to go there. So what you will do to football? Is it possible football will go by itself? Then what is the use of player? Correct or not? Correct. You can control the football without playing. Correct. So why players are needed? To make a goal. to provide external force. Are you getting or not? This football is coming like this, and goal is here. So football is coming like this. Goal means football should go here. Means what you want to do? Change direction. You want football to go here. So now the player, role of player is now. This person is standing here. Okay. So what this person will do? Change the direction of football by how? Legs. So shoes. Hit the ball. Hit hit football. So when it is hitting the football, what it is doing? Huh? What type of force it is exerting? Balanced or unbalanced? Unbalanced. So person is this person will hit the ball. Okay. So it is exerting unbalanced force. That's why the direction is changing. Okay, clear? So to change the direction, unbalanced force is needed. So if rest or uniform motion, forces are balanced. Okay, remember. So let's solve some Lami's theorem. Also, I am revising Lami's theorem. It is very important. So suppose Lami's theorem is we have done in vector, right? Lami's theorem. So Lami's theorem is applicable for how many forces? Three forces. Three forces in equilibrium. Three forces in equilibrium. Okay. Don't worry, I will go slow only. I am not going fast. We have enough time, right? 4 hours. Okay. Three forces in equilibrium. So three forces will be like this. One force like this, one force like this, another force maybe like this. Okay. So like this is 90-degree, and suppose this is 150-degree, then this force is 3, and this force is F1, and this force is F2. Can you find relation between F1 and F2? Levi's theorem, remember or not? Tell me. Suppose three forces are there like this: F1, F2, F3. Opposite to F1, what is the angle? Alpha. Opposite to F2, what is the angle? Beta. Opposite to F3, gamma. So what is the relation between these forces? F1 by sine alpha is equal to F2 by sine beta is equal to F3 by sine gamma. Okay. So this is the, now can you apply this here? Find relation between F1, F2. Means basically you have to find ratio. Find F1 by F2. How to solve this? What is the complete angle for one round? What is the angle? 360, correct? Now 90, 150. So tell me what is this angle? This angle, tell me. 360 minus 90 minus 150. Are you getting or not? What is this complete angle? Complete 360. So 360 minus 90 minus 150. Tell me how much? Tell me how much? 120. Okay. So 360 minus 90 is 270. Then 270 minus 150 is 120. Okay. So this angle is 120. Correct? And this, you know, these formula also a little bit I have discussed before. Sin 90 plus x. What is sin 90 plus x? Cos x. You can assume theta also, sin 90 plus theta, and sin okay, fine. Okay, fine. Sin 90 plus theta is cos theta. Okay, remember. And what is cos 90 plus theta? Cos 90 plus theta minus sin theta. Okay. Okay, fine. So you got any answer? So how will you write now? F1 F1 by sin 150 is equal to F2 by sin 90 is equal to 3 by is equal to 3 3 by sine 120. Okay, clear, understood. Are you getting? Uh, Now we are doing exact NEET question. Are you getting or not? This is proper NEET question. So three forces are there. Lemmy's theorem is applicable to equilibrium, means forces are balanced. Okay, so balanced forces. Okay, so balanced forces are there. Three forces are there. Lemmy's theorem applicable to three forces. Fine. Okay. Now find the ratio between F1 and sine 150. Tell me what is sine 150? Cos 60. Very good. Okay. Cos 60 F2 by 1. Sine 90 is 1. And what about sine 120? Sine 120? Cos 30. Very good. Cos 30. So now F1 by F2 you can write F1 by F2. F1 by F2 is equal to cos 60. And what is cos 60 value? 1 by 2. So F1 by F2 is 1 by 2. Okay, clear? Understood? Hmm. Okay, easy, right? Any step you tell me. So Lemmy's theorem. F1 by F2 is 1 by 2. Okay, answer, question solved. Now suppose if I ask what is F1 and how much is F2? If I ask how much is F1 and F2, then you have one more here, 3 by sine 120. So now you tell here, equate these, equate these. So F1 by sine 150 is equal to 3 by sine 120. So F1 by cos 60 is equal to 3 by cos 30. So F1 is equal to 3 cos 60 by cos 30. Is it difficult? Tell me, is it difficult? Okay, everyone getting? Okay, 3 into 1 by 2, root 3 cos 30, root 3 by 2. This 1 by 2, 2 to cancel. So 3 by root 3. 3 by root 3 how much? Root 3. So F1 you got root 3. Okay. And F1 by F2 is 1 by 2. F1 by F2 is 1 by 2. So what is F2? 2 F1 and F1 is root 3. So what is F2? 2 root 3. Okay, F2 is 2 root 3. Okay, clear? Like this, you have to solve. So that is Lemmy's theorem example. Okay, very important. So Newton's first law. Newton's first law, balance forces, equilibrium, okay, rest or uniform motion. Rest or uniform motion, balance forces, equilibrium. Remember these things. Okay. Okay, so now next, Lemmy's theorem. Okay, one example. I am not going in detail. Now you practice some questions later. So now I am going to normal forces. So note down normal force. What is the symbol for normal force? N. It is a contact force. Note down. Push force. Push force and contact force. Push force and it is a contact force. Contact force. Contact force. Note down. Push force or contact force. See, let's take two examples. One example, one student is there, and another example, elephant is there. Okay, elephant, four legs are there. Okay, student, two legs are there. So legs are in contact. Legs are in contact with the ground. So both legs will experience normal force. Normal force. Elephant, how many legs are there? Four. So all four legs will experience normal force. Okay, where contact is there, contact is there means normal force is there. Okay, suppose some animal is there and five legs are there. Okay, so all five legs will experience normal force in upward. So Who is exerting normal force here? Tell me. Who is exerting? Surface, ground. Okay. And what is the direction? Upward. Why it is? Because it is push force. Correct. Now, let's take one more example. Now, let's talk about ceiling. Ceiling. Okay. Now, there is a box. There is a box, and this is student is holding this box like this. Okay. Student is holding like this. So, what ceiling is doing with the box? Pushing the box where? Down. Okay, like this. This is a ceiling, and now I'm holding the box like this. Okay, so now ceiling is exerting normal force where? Downward. Okay, ceiling. So normal is always upward. True or false? False. Okay, so this is one important concept. Normal x upwards always. Okay, so this is false. Remember, this is false. Okay, normal is just a force. It can be rightward, leftward. Now, what is the direction normal? Suppose I'm holding, pushing this wall like this. What is the direction of normal? Now we are normal, outward. See, suppose this is the wall. Now this is student is there. It is uh, it is pushing the wall. The student is pushing the wall. Student push wall. Student is pushing the wall. Where? Student pushing the wall like this, like this. So what is the direction of normal on the student? Rightward. Correct. This is the normal. Okay, understood? Okay. So normal can be upward, normal can be downward, normal can be rightward, normal can be leftward. Suppose the wall is on the right side. Suppose wall is on the right side. Now the same student is pushing the wall like this. Now the normal force. Okay. So normal force on the student will be left. Okay. The wall is pushing the pushing the person left. Okay. Here wall is pushing the person right. Okay. So normal is always upward. That is wrong. Okay. It is false. Okay. So normal is a push force or pull force. It is a push force. Remember, normal is a push force. It is a contact force. If contact is not there, means no normal force. Let's take one more example. Again, one student is there. Okay. Okay. So what is the direction of normal on this person? Upward, and weight downward. So that is mg. Okay, both are balanced, correct? Now this is a small child. Now one big person is there. So it is holding the head of this child. Okay, holding the head of the child. Okay, trying to lift it. Are you getting or not? Person is trying to lift the child up. Are you getting or not? So normal force will increase or decrease? Normal force from ground will increase or decrease? It will decrease. Very good. Why? Lesser and lesser. Correct. The contact from the ground is losing. Okay. So when big person, this is a big person, this is small child. Okay. So when big person is lifting, you're holding it and lifting. Okay, lifting small child. Contact is losing. Contact is losing. Okay, contact is decreasing. When it is fully lifted, now child is in air. When child is in air, what will happen? Child is in air. What is the contact? Zero. No contact. So what is the normal? Zero. Correct. So when big person is lifting, small child contact is losing. Losing means decreasing. So normal force decreases. Okay, so you can assume, you can see, suppose the weight of the child is 40 kg into 10. Okay, so how much is normal? Suppose mass of the child is 40 kg, so what is the normal, tell me? 400. Now you are lifting the child. So what is the direction of your force? Upward. So normal force will not be 40. So suppose you are exerting 10 Newton. This is the external force. So how much force you are exerting? 10 Newton. So what is the new value of normal? 390. Very good. Then when you are exerting 80 Newton, suppose you are exerting 80 Newton, you are holding the child and you are exerting 80. This person is exerting 80 Newton. So what is the new value of normal? Correct. So normal is decreasing. Okay. So now, so this will be 320. Normal will be 320. Are you getting or not? So what is the minimum force you have to exert so that normal becomes zero? Tell me. 400. Correct. Good. So note down. Very good. So if person, this big person, this big person pull child with 400 Newton upward, normal becomes zero. Normal becomes zero. Normal becomes zero. Are you getting or not? So normal means contact force. So contact is lost. Okay, contact is lost. Okay, clear? Okay. So now let's take one more case. Suppose this is a student standing. Now the same person is uh, pushing the child down. Push. The person is pushing the child down. Normal will increase or decrease? Now it will decrease. Now this normal will be more than mg. Are you getting this point or not? Okay. So in this case, the force is upward. You are holding the child and pulling it up. So this force is upward. So normal will be less. Normal will be less. Okay. N is less than mg. Correct. Now in this case, what is going on? You are pushing the child down. So normal will be more than mg. Suppose F is 10 Newton and mg is 400 Newton. So how much is normal now? 410 Newton. Okay, clear? So normal will be more. Okay. So normal is self-adjusting. You can say normal is constant or it can change. It can change. Normal can change. So normal is always mg. True or false? False. Correct. Yes. Huh? Normal force on the big man. Yes. Correct. Good question. So let's solve that. So suppose it is good question. Now this person is also experiencing normal force. So this person is exerting 10 Newton on this child where? Down. So what is this force? Force exerted by big person on child. Okay. So this child will also exert force on big person up. So suppose if you draw a free body diagram of big person. Okay. Suppose mass of big person is 100 kg. Okay. So what is the weight? 1000. Okay. Mg. Now force on child is downward 10. So force on person will be upward 10. Are you getting? So who is exerting this 10? Who is exerting this 10? Child. On what? Big person. So this is the force on big person from child. Okay. This is the force on child. Okay. And normal force will be upward. So how will you calculate normal force now? What is the upward force, resultant upward force? N plus 10. And what is the downward force? How much? 1000. So what is the normal force? 990. Okay. So normal force is increased or decreased for the big person? Decreased. Okay. Decreased. Correct. Good. So if you want, you can note down this example. Okay. So normal force on the child is decreasing. Oh, sorry, increasing. Normal force on the child is increasing. And normal force on the person is decreasing. Okay. And one more example, practical example is there. So suppose one student is sitting. Sitting means on the floor. So suppose the person is sitting on the floor. Okay. Now hands are there. These are the hands. So how to stand? You are sitting on the floor. How to stand? You will use your hands. You will push the ground. Correct. You will push the ground like this. So why you are pushing the ground down? So that the ground will push you up. So ground will push you up. Okay. You are pushing the ground down. So ground will push you up and you will stand. Correct or not? Correct or not? Okay. Correct. Good. Okay, fine. Now I will not go in more detail like this. I will stick with our questions. So, okay, so I'm talking about normal force. So write down question, write down. Find normal force. Find normal force in all cases. Okay. Now we will use vectors also. Okay. Use vectors. Okay. So 10 more minutes. Oh, okay. So solve first. Now you can answer. I'm 100% sure you can answer all the questions. It is easy. You will find these questions very easy. Okay. So there is a block. What is this surface? Surface means horizontal surface. Okay. All surfaces are smooth. Note down. All surfaces are smooth. All surfaces are smooth. So no friction. Now this is 2 kg. 2 kg box. What is the normal force? Tell me. Take G as 10. Okay. So 20, correct, good. So you solve like this. So you tail, common tail, downward is mg, mg means 2g, 2g means 20, and upward is normal, understood? So n is equal to 20, correct, good. Now next example. This is the 2 kg, and external force is there. External force is there. External force is 5 Newton. 5 Newton external force. Now, how will you solve this? External force is there. So, again, common tail, downward what force? What is the force downward? Mg, mg means 20. And normal force will be where? Normal, where? Upward. Normal is upward. Good. Normal is upward. And this 5 Newton external force? Downward. So, how many forces downward? 2. How many forces upward? 1. So, forces are balanced. So, n is equal to 5 plus 20. So 25. Correct? Value of normal is 25. Okay, clear? Understood. Correct. Good. Now, this is the wall. This is the wall. It is a smooth ball. Okay? It is a smooth ball. Now, this is 2 kg and you are exerting force like this. So, find force F. And normal also. Find F and normal. If block at rest. If block at rest. Block is at rest. So, what is the normal force? Okay. And like it is like this. So, this is the object. It is like this. Okay. This is the box. You are exerting force like this. Okay. If you release the force, it will fall. So you're holding, you have exerting force like this. You are exerting. Okay. So how many forces? So free body diagram. So draw free body diagram. This force, common tail. Okay, with common tail. This is the force. Draw like this. With vertical, what angle it is making? With vertical, this is 53. So this angle also 53. Okay, wall will exert normal force where? Left. Normal force is. Are you getting or not? This is the wall. It will exert normal force on 2 kg. Where? Left. Weight. What is the weight? Mg 20. Okay, understood. Now you can use Leibniz theorem. Use Leibniz theorem. Two methods are there. What is the question? F and N. So two methods are there. Using component and using Leibniz theorem. What you want to use? Tell me. Which method? Leibniz theorem or component method? Tell me. Okay, let's use Leibniz theorem. What is the angle opposite to normal? Angle opposite to normal, tell me. This angle. Okay, what is this angle complete? 180. So this is complete 180 and this is 53. So what is this angle? 180 minus 53. So how much? Correct? 127. And what is this angle? 90. And what is this angle? 90 plus 53. Okay. 90 plus 53. So what is angle opposite to F? Angle opposite to F? 90. Angle opposite to N? 127. Angle opposite to 20 Newton? 90 plus 53. So Leibniz theorem, how will you write? N by sine 127 is equal to tell me F by sine 90. Good. F by sine 90 is equal to 20 by 20 by 20 by sine 90 plus 53. Correct? Correct. Good. Now sine 127, tell me how much? 4 by 4 by 5 or 3 by 5? 4 by 5. Okay, correct. Good. So sine 127 can be written as cos 37. And cos 37, you know, 4 by 5. Very good. Okay. 3, 4, 5. You know this triangle, we have discussed this vector. Okay. So 3, this is 5, 3 angle. What is that? 53. This angle? 37. Correct. Good. 90. So cos 37 means adjacent by hypotenuse 4 by 5. Okay. So this is 4 by 5. And what is sine 90? 1. Then cos 53, tell me. Cos 53, 3 by 5. Correct. So this is n by 4 by 5 is equal to f by 1 is equal to 20 by 3 by 5. Okay. You use this, you can find answers. So what are the answers now? So I'm solving this. 5n by 4 is equal to 20 by 3. And 5 will go to the numerator. 20 into 5 by 3. Okay, 5 cancel. So n is equal to 20 into 4 by 3. So what is the answer? Final answer? 80 by 3. Correct or not? Tell me. Correct? Normal is 80 by 3. Okay, fine. Now what is f? Solve. Equate these two. Equate these two. So f is equal to 20. This 5 will go to the numerator. Okay. So 20 into 5 by 3. So what is the answer? 100 by 3. So what is the value of f? 100 by 3. Value of n? 80 by 3. How many understood? Tell me how many understood? Raise your hand. Those who understood. Okay, good. Okay. Okay. See. Okay, note down question. You try once again. Okay, I will discuss this again. Okay, I'm now will discuss next 9:15. We'll continue. Okay, fine. Take break. And you ask for a DPP, okay? Practice. They will give printed, okay? Printed DPP.